So we're asked to integrate the function of x times e to the x squared with respect to x using u-substitution. The first thing I want to do is I want to set a portion of my integral equal to the variable u. So pause right now and see if you can determine which portion of the integral to set equal to u. Alright, so I'm going to set u equal to x squared. And the reason why I'm setting u equal to x squared is because x squared is within the function of e to the x. So if you need more of a visualization, f of x is equal to e to the x. And I'm plugging in x squared into the function. And that is going to be equal to e to the x squared. So as you can see, x squared is within the function of e to the x. And that is why I'm setting it to my variable u. So now I'm going to rewrite the integral of with the u variable, so I get that the integral of x e to the u, and we're integrating with respect to dx, as you can see right there. Now what I'm going to do is I'm going to differentiate u, this u equation, and when I differentiate u, I get the derivative of u with respect to x is going to be equal to 2x. And the reason why this is 2x is because I used the power rule. Now I'm going to solve for dx. I'm going to multiply both sides by dx. As you can see right on the left hand side, the dx in the numerator cancels out with the dx in the denominator, and I can rewrite this as du is equal to 2x multiplied by dx. Now I'm going to divide both sides by 2x. As you can see, these cancel out, and we can just simplify this to du over 2x is equal to dx. Now that I solve for dx, I can finally plug this back into my new integral, and this integral is going to be the integral of x times e to the u being multiplied by du over 2x. I'm going to rewrite this integral so you guys can see the cancel of terms. As you can see, I have an x in the numerator and x in the denominator. I can cancel these out. And as you can see, e to the u is being multiplied by 1/2, a constant. So I'm just going to undistribute the 1/2 to outside of the integral. So I can rewrite this as 1/2 multiplied by the integral of e to the u, and we're integrating with respect to u. So now that we simplified this integral, we can finally just use the formula for integrating e to the u to solve for this integral. So when I do that, I get that our answer is going to be 1/2 e to the u plus c. But keep in mind, we can't have u being in our final answer, so we need to make the substitution of u equals x squared. And if we rewrite this, we plug this into here, we should get that 1/2 e to the x squared plus c is our final answer. And you can check this with differentiation. So we're asked to integrate the following function of x multiplied by radical x plus 1, and we're integrating with respect to x. The first thing I want to do is I want to set a portion of the integral equal to u. So pause and take a moment to determine which portion. So I'm going to set u equal to x plus 1. The reason why I'm setting it to x plus 1 is 1, it's under a radical, and 2, it's clearly the longer of the two expressions, so that is why I'm setting it equal to u. Now we can rewrite the integral as the integral of x multiplied by radical u being integrated with respect to x. Now I'm going to look at this u equation right here, and I'm going to differentiate it. So when I differentiate it, I get that the derivative of u with respect to x is equal to 1. Now we're going to isolate for dx. The way I'm going to do it is I'm going to be multiplying both sides by dx. As you can see on the left hand side, the two dx's cancel out, and you're left with du is equal to just dx. Now that we have this equation right here, we can substitute it back into our new integral, and we get that the integral of x being multiplied by radical u is going to be integrated with respect to the variable u. Now you might be asking yourself, well, the u substitution didn't cancel out the x term, so how are we supposed to integrate this with two variables? Well, we need to look back at our original u equation, And we're going to need to solve for x. And then once we solve for x, we're going to plug it back into our new integral. So I'm going to solve for x here by subtracting -1 from both sides. Or that looks like I'm dividing. Excuse me. U equals x plus 1. I'm going to subtract from both sides. And this is going to be rewritten as u minus 1 is equal to x. This is going to be plugged into here. And what we should get is our new integral is going to be the integral of u minus 1 being multiplied by a radical u. And this is all going to be integrated with respect to u. I'm just going to simplify this using algebra. I'm going to be distributing radical u into the parentheses. So when I do that, radical u I'm just going to rewrite as 1/2 for 1/2. So it's a little bit easier to see. Multiplying u and u to the 1/2, I should get u to the 3/2. And that's going to be subtracting by u to the 1/2 times 1, and that's just u to the 1/2. And that's still going to be integrated with respect to u. Now if we look down here, we can just use the basic power rule in order to solve for this integral. So if we use the basic power rule on u to the 3/2, we should get that u to the 3/2 plus 1, and that should be divided by 3/2 plus 1, subtracted by u to the 1/2 plus 1 over 1/2 plus 1. And because we're integrating an indefinite integral, we have to add the plus c. Now let's simplify this a little bit. 3/2 plus 1 is going to be equal to 5/2. So 5/2 in the denominator as well. And u to the 1/2 plus 1 is going to be equal to 3/2. So it's going to be u to the 3/2 divided by 3/2. And then still by plus c. As you can see, this is a complex fraction, so we're going to rewrite it. And when we rewrite the complex fraction, this should be 2 multiplied by u to the 5/2 over 5 minus 2 to the 2 times u to the 3/2 over 3 plus c. But don't forget, we still have to substitute u with x plus 1, I believe. Yes, x plus 1 into our answer. So when we do that, we should get 2 multiplied by x plus 1 to the 5/2 power over 5 minus 2 times x plus 1 to the 3/2 power over 3 plus c as our answer to the integral.